Hello, everyone. Thank you for joining me today to talk about the Comet platform. Today, I'm going to talk about the power of the Comet platform and how you can streamline your machine learning experiments in this platform. So what is Comet? Comet is a cloud-based MLOps platform that helps you to manage and optimize your machine learning experiments. It is developed in 2017 by a team of data scientists and machine learning experts, and it can be used from academic teams to startup and to enterprise companies. Here you can see some of the companies that they're using the Comet. For example, we have Uber, Netflix, Etsy, Shopify, and other companies that you can check them out in their own website. So what is the key features of Comet? Comet offers powerful features to streamline machine learning workflows. You can track metrics, hyperparameters, and prediction within it. It helps you to centralize experiment management for reproducibility. It works with Jupyter Notebook and 100% free. It also has the enterprise account, but for the small groups, the free version works fine. And it provides visual tools to analyze and compare experiments, and it enhances collaboration by sharing experiments across teams. Also, Comet integrates with most of the machine learning frameworks. For example, we have TensorFlow, Keras, PyTorch, Scikit-learn, Matplotlib, and also it can be linked to your GitLab account. So here in this link, you can see all the long list of all the frameworks that Comet can work with. So how do you, before going to talk about the how can start with Comet, I'm going to show you the framework itself. So here is the Comet's website. So you have to create an account and log into that, which will give you this space. So this is called a workspace, and everyone can have many workspaces. So here I only have one, but if you're working on different projects, you can create your own workspaces. So by just doing the create workspace here. Here I have different projects that I'm working with for this seminar, and you can make each of these projects visible to public, or make it visible for yourself, or also add some collaborators to a project, which I will show you later. So let's get back to the slides here. So how can you start with the Comet? So to do that, you have to install the Comet's ML libraries. If you're working on Colab or other platforms, so you can easily just pip install them. But if you're working on our clusters, because it needed the internet to connect with the Comet and get the data from your code and insert it in the Comet, you should have the internet access. So on Narwhal and Beluga, which I'm doing my codes on, you first have to load the module HTTP proxy, and then you can install the Comet, which is installed in our wheel. So this is how you can do that. And also, like GitHub, you have to set the API key. So to do that, there are two ways. The first one is using this comet_ml.login, that you can put your API key here. And the other way is just create the file .comet.config and put your API key there. I prefer the second one because it is more secure, and you shouldn't have to do that every time that you're writing a new code. So if you prefer the first one, every time you have above your code, you have to put your API key, which will not be may not be desirable. So what I've done is I'm just creating that comet.config file and put my API key there. Okay, so if you want to start with Comet after installing the Comet_ML, you have to import it, first of all, and then log into the Comet, whether inputting your API key here or doing the other way that I showed you. Then you have to import experiment from the Comet. And here's how you can define your experiment, giving it a project name and the workspace, if you have more than workspace. If you do not, this is completely optional, but you have to specify your project name. Otherwise, it will be put on unnamed project that I will show you later. Then you have to put all other of your codes that you want to run. And at the end, you have to end your experiment. So this is the some specific lines that you have to do every time that you want to write your code to use the Comet. So let's see the Comet here. Where can you get the API key? So if you click on your profile picture here, here is your API key. You can copy it and use it to be connected to the Comet. And other thing that I want to show you is if you do not put a name to your project, it will be become here in uncategorized experiments. So it's better to give a name to each of your project that you're doing. And if you want to change the setting for this visibility, you have to just click on the setting. You can edit it, make it public or private. And also you can share those and add some collaborators, create shareable links, and add collaborators to your workspace if you want to share these with your colleagues, with your teams, and other peoples. So this is the basics for the Comet, but I've created some code that I want to show you how you can use with the Comet. I've run all of my code on Narwhal with 1 core of GPUs and 4 GB of RAM and 1 or 2 CPUs. But just for the sake of showing you today, I'm using the Jupyter Notebook on my local computer. The codes are just the same. I'm just doing this to be easier to show you the code here. And also, if you want to have more information about the Comet, here is our wiki page, which tells you that if you want to use the Beluga or Narwhal, you have to load the HTTP proxy first. If Cedar, it has internet access enabled, so you're just needed to install the Comet. And Graham, unfortunately, we do not have the internet access, so it cannot be worked on the Graham. So let's get back to the codes here. The first code that I've used, I just want to show you the metrics for the training and like accuracy and loss, defining the loss here. So I'm not going to deep to the codes. They're just some simple deep learning and machine learning codes. What I'm going to show you today and emphasize on it is how you can do that within the Comet. So I'm using the MNIST dataset, and do the classification for the deep learning. So first of all, I have to import the Comet and log into that. You have to import the experiment from the Comet ML here. The other libraries is just for the codes and the deep learning codes that I have. I load my datasets, I'm reshaping them and convert them to binary class metrics. I defining my model like every deep learning codes that you may do and building it. And here I defining my experiment, giving it my project the name of the confusion matrix. Here, if with this experiment.display, you can have some view of your Comet here. So some may prefer to work with this one here rather going to the Comet website, and therefore it must be easier for them. So with this Comet display, experiment display, you can have that. I defining some parameters. compiling my model and the summary of my model. So nothing special to Comet here. But then here, if when you want to train your data, I define the validation set and the training set here. So I want to have the information of the accuracy and loss function for each of these data sets. So what I have to do is just when I want to train fit my model, I'm using the syntax with experiment.train. The others is just the same. I feed them my model, giving it the name xtrain and ytrain, the number of the epochs, the batch sizes, and defining the validation set. And but just simple syntax, it will do that, and it will give me the metrics for the accuracy and the loss function. So here I define the loss for that, but I will show you this codes later. I predict my model, and here I want to have plot the confusion matrix for this special case. So this is just easy. What you have to do is just using this log confusion matrix command with the experiment here, giving it the true value and the predicted value, and it will plot you the confusion matrix. The last thing that I want to show you in this code is how you can log some figure. Here I just plot the MNIST, small number of the MNIST dataset and the prediction, and I want to log this figure in my Comet platform. So I only have to do this log figure, giving it the name and the figure itself. And at the end, I will do this end my experiment. So what will it look like in the Comet? So here is my project here. You can see that I have more than one run. So I have more than one experiment of this code, which all be here. You can follow them and see that they are all be visible here. If you do not want to see some specific of this experiment, you can easily hide them out. So yeah, it will be less experiments will be looking here. So these codes are all the same, so the results are not differ from each other. But if I want to show you some of them closely, for example, this one, this is how it will look like, the metrics that I've had. So I have my train accuracy, I have my train loss, I have my validation loss, and the validation accuracy. So the validation loss here, the validation accuracy, train loss, and also it has some train epoch duration and train batch accuracy, which is a little bit different than train accuracy, but have the same trend, just a little bit more noisy here. Another thing that you can do is you can filter them by here number of the epochs, for example, steps. It will take some time to be loaded. Yeah, but yeah, you can filter them by this x-axis and it will show you the results. So what other things that you can have in Comet is the code itself. So you may use others' code within the Comet platform that people share. So you can have here by this code, have access to their code. So you can use them, get some idea from their code. So it is beneficial here. Also, the hyperparameters that you're using, for example, the optimizer here was GD, and all others learning rates, and every hyperparameters that you're using in the code will be shown here. In the metrics, you can have access to the metrics that we had, I've shown you, like train accuracy, train loss, validation accuracy. For the last amount, the minimum amount, and the maximum amount. So you can have this information that may be useful for you. Here, another thing, we have system metrics. So you can have the metrics for your GPU utilization, GPU memory usage, CPU usage, the network, and everything else. So it will shows you how optimized your code is. The code here is not optimized really at all. but that was not the purpose here. So I have my GPU memory usage here, GPU temperature, network usage, CPU utilization, memory, and disk utilization. So it will help you to optimize your code. You have all the installed packages with the versions. So when you want to use another person's code, you know what libraries you have to use. Here we have graphics, the plot that I logged, and here you can find it here. So it is the MNIST data set and the ones that is predicted. Comet is really useful if you want to just do the presentation. You can just download the images from there and it will be much easier. And here the confusion matrix that I want to show you. So here I have my confusion matrix for each of the classes. For example, if the number was 0 and it was predicted 0 and other values here. So you may need a confusion matrix for one of your codes, and here how you can log it and how you can use those. Get back to the first page here. Besides these metrics, you can create your own metrics here. For example, this is what I've done. Here I plot the train accuracy versus the train loss in each epoch. So you can also create yours. To do that, you have just this add panel. It will give you some charts here that you can use, line chart, scatter chart, bar chart, and other things that I will show some of them later. So I did the line chart. And here, for example, for the x-axis, I want to the val loss and val accuracy. So the metrics are all here because I logged them. So I just select them and you can just do the smoothing if you want, but I prefer not to. And done. And it will be just shown here. So you can create your own metrics if you needed one. And okay, just done with this part. Let's get back to other codes. So when you're doing the deep learning code, sometimes you may have the exploding gradient or the vanishing gradient. So these two are some phenomenon that you should avoid. But you have to know the signs that you are, whether it's exploding or the vanishing gradient. So what I've done here, I log the weights in the exploding gradient code that I've written using MNIST to maybe use that with a sign that you are in the exploding gradient. So the code is like before, importing Comet, log into that, importing the experiment here. I built different model for that so that I be sure that I'm in the exploding gradient. I put my learning rate as 8, which is a lot, which is huge. And I compile it and the model summary. So the method that I use to calculate the weights is called the logging callback method that you can look up and use it if you want. So this is written in the class forms. So for that, I put the self.experiment as an experiment here and getting the weight with the self model.getWeights. Naming the layers for the bias or the other weights for each of the layers. And here I'll log it. I use the experiment.log histogram 3D, giving it the name and the value of weights. So here I read my classes so that they could calculate the weights for each of the layers. But then you have to create an object from this class with the experiment as an input. I called it the CB here. And when you're training your model, like the ones that I showed you before, you have just to call it here and make the callback as the CB that you created here. And by this, it will log the weights for you. So all you have to do is using this login callback method, create an object from it, and put it when you're training your model with this experiment.train. So let's look at those. Yeah. So because I'm in the exploding gradient, the accuracy loss, everything is a disaster. So this is not what I want to emphasize it. What I want to show you here is the histogram. So here is, if I just, yeah, you can see better. So here is the weights for each of the layer, the bias and the other weights of each layers. You can see the amount of the weights is huge. So it's a histogram. The z-axis is the steps for each running of the code and the amounts and the number of the bins. So yeah, the weights are huge here. As you can see, there are, yeah, for example, here it's, yeah, too much. So it could be the sign that you are in the exploding gradients by just logging the weights in your code. So this can be useful. And for the vanishing gradients, I also like the gradients. So we can have better idea if we are in the vanishing gradients or not. So here is the code for that. Everything is the same. I created different kind of models, making my learning rate small at 0.0001, which is really small. Compile my model. Here how I like the weights, as I've shown you before, and here the loss function. So the loss function that I used is categorical cross entropy. So I've calculated the losses with the tf.gradient tape syntax here. I predicted my model and calculate the loss function here. And for each of the gradient that is computed, I log it with the histogram 3D method. And for each epoch, it will be logged. So this is how you can do to log the gradient for your models. Here, and the rest is the same as we've done in the exploding gradient code. So let me show you that. So, for example, here, if I go to the histograms, yeah, here it is. So first, this is the layer that we logged. So you can see this is a little bit small. So it's in the micro zone and it's become smaller. So this will be maybe a sign that we are in the vanishing gradient, but we cannot know for sure. But if I go and show you the gradients, you can see they are too much small. It's 50 nano, 20 nano for the biases. And so the gradient is so small that it can maybe, that will show us that we are in the vanishing gradient zone and we should do something to avoid those. For example, increasing our learning rate. So this is how a gradient will be for each different layers that we logged here. So yeah, but if you want to see what will be the normal codes and some successful code the gradient will be, this is what I've done in the confusion matrix. The first code that I've shown you. Now I want to show you how the normal ones should be. So this is the gradient for some successful code will be. They're not that much small, so it could be reasonable, the amount of the gradients here. So this is the different from the vanishing gradient and the code that is doing been running successfully. So let's see what codes I have next. Sometimes when you're doing your code, you may not know the best parameters to use. and you want to do some search on it, for example, using the grid search or the random search for the parameter optimization. Comet here really gives you the best insight to what parameters you can use. So the next code is how you can use parameter optimization within Comet. So here is just the same as before. I have some models here, train it with some specific parameters, and here. So to do that, first you have to write this configuration. We have to specify what the configuration will be. I'm using the random algorithm to do the random search for it. And I asked it to be a maximum 15 combination of the parameters that I've specified. And my object is to minimize the loss function. So we can use other objects and a specification and also the parameters. So just for showing, the parameters that I use, the first one is the first layer units, which the type is integer. It could be between 8 to 64. The batch size would be either 8, 16, or 32. And the learning rate with the type is float, which can be from 0.001 to 0.01. After creating this config file, you have to use this Comet optimizer and give the config as an input to it. So you have to use the optimizer in the Comet. I called it the OPT here. And for each of the experiment in this opt.get experiment that you're using the combination of the parameter that I'm giving it, it will log the parameters, building the model, training it, and evaluate it. And at the end, I will end my experiments here. So you have to give the configuration and your parameters using this Comet optimizer syntax. And for each experiment, it will log for the parameters that you're looking for. So it will be, yeah. Okay. So here is how, as I mentioned, I used a maximum 15 numbers of parameters combination. So I have 15 experiments here. And here, as you can see, there are metrics that you can choose from. So for example, I want to look at the loss here, training loss. I will make it bigger. And it will shows me all the 15 experiments here. You can put a name and tag for each of the experiment that I will show you in the next slide, how you can do that. And okay, for example, I want to choose some loss function that are the smallest. So for example, here, the continuing, right, okay, I'm gonna find this and I'm gonna look it up close. So the accuracy, the loss function, everything's here, you can find it. So you can compare the results with each of the parameters that which one is doing better. And if you want to know which hyperparameters this code is using, you can just go to the hyperparameter, is use the 32 as a batch size. And the first layer unit is 43, and this is the learning rate that it's used. So by this way, you can have better idea of what parameters may better suit you. But if it's too much to choose which one of these you want, you can also create your own panel metrics. So here I use, for example, the accuracy. So maybe this will show us better how we can use that. So for example, here is the one that I showed you. It has the best accuracy here, but if you're looking for other metrics, you can add them to your panel. For example, here I use add panel. I use the bar chart here. And I like the violin plot. Here we can see the validation loss, for example. I will add those, and here you can choose by the validation loss that which one of these parameters will suit your code better. So yeah, you can add many panels, bar charts, you can change the colors, anything. So this is how it's done. So now I talked only about the deep learning code, but also you can use it for the machine learning purposes. So the next code here is some classification code. Show that. I use this diamond data set. It has some information about the carrots, cut, color, clarity, and other information. What I've done, I want to analyze it as a classification. So the cut here is my target. Maybe it's not the best target to use, but it's just for the case of showing. So if the cut is ideal, premium, or very good, I put it in the category as a gold, and otherwise I put it as a category in silver. So what I've done with this data set, I just log into that, dropping this first column that we do not need. I changed these columns that they are not in numbers, so it may be hard to analyze them. And a standard scale all of those, and put in my target as a cut that I mentioned here, and build my data set. So I split my data set as a training and test data set, and here what is important. So what metrics that I'm looking for? I'm looking for the precision, recall, F1 score, and the accuracy. So here is how I define them with this compute metrics function that I used. And so for I created this run experiment function here. I will give it the name of the model, the class algorithm that I want it to use for my classification. I set a name for each of these algorithm and also tags, so I can follow them better. So this is how you're doing it. And with this, like before, with experiment.train is how I logged my metrics. So I fit my model, predict it, and compute the metrics that I've mentioned here, log the metrics, and also log the confusion metrics. So I've done it for the training and also validation set. So all you have to do is just log the calculate the metrics here and log those within the Comet here. And also I end my experiments. So what algorithm I used? I used the random forest classifier, decision tree, Gaussian, Conan, and the SGD classifier. So let's see how they will look like. So this is how it is run. So I have my train accuracy, train F1 score, precision, recall, validation accuracy, precision, and other metrics. You can see that they have names because I set name for those. They have this specific color, so you can better choose which one of those you'd like to use for your code. So if you look closer, we can see that the random forest here and the decision tree are better in most of the cases. So we can, for example, use those. But you have, for example, here, if I like to look at the decision tree, the train accuracy is 100%, F1 score is 100%, like the precision here, and the validation is somehow different. So the validation accuracy is 94, the F1 score is 77%, recall 77%, and the validation precision is also 77%. So this is the metrics for that. So if I want to show you the confusion matrix, you can see that I have the confusion matrix for the training and for the validation set. So for the training set is overfitting somehow, but we can see the results that in the validation, it's not like this, and we have more reliable results, but maybe we can do better with adding some parameters or using other data algorithm. So another thing that you can use for the machine learning purposes is using the ROC curve. So that I've plotted here. And by that, you can see that random forest and decision tree has the most ROC curve here. So how you can plot the ROC curve is by just adding a new panel here. Here in the public section, there are many plots and panels that you can use that others just created that may be useful for you. So by using this ROC curve here, I can add those in my panel here. So I'm just adding them. If you want, you can edit the code. So by just editing this, you can either change the color, change the title, or anything else. So you have the ability to change the code here and add them to your panel. I'm just using the default ones and done. So again, I have the ROC curve just like the same that I wanted to show you. So the last thing that I want to show you is something fun, maybe. With Comet, you can track the carbon emission that your code is using by the resources that you're consuming here. So this is the carbon code. And for that, you first have to install the code carbon if you want to do that, and import the emission tracker from it. You have to start the tracker here. And the tracker is defined by using the emission tracker. I want to measure my power every 30 seconds. I just given it my GPU IDs here and start the tracker here. You have your code here. I have to run it for 250 epochs, which was really unnecessary, but I just want to have some numbers. So, and then you have to stop the tracker and log the metrics of carbon emission. And it's the name and the amount that it is calculated. So how it is in Comet. Okay. It will give you this one. So it can figure out that the infrastructure is hosted in Canada. The power consumption is 0.02 kilowatt hours, and it is look like that you're using 0.03 minutes on your 32 LED TV. I didn't run the code for much. The code is just easy. It's using just one core of GPUs. So this is not much to consume. You can select this carbon for each of the experiments that you have, or also aggregate those if you are having each of your experiments doing one part of your code. So this is how it will be done. So I'm done with the code. Let's get back to the slide. I put the important part of each code. That's how you can log the metrics. I just put it in the slide, but if you want to use it later. So yeah. So to wrap up, why should we use Comet? So as you see, it was really easy and has a user-friendly interface. It offers a centralized platform for managing ML experiments. You can track, monitor, and compare your experiments in the real time. You can log hyperparameters, metrics, and data visualization. It's really great for just presentation. and it integrates with popular machine learning, and also is cost-effective option for small-scale machine learning projects. And thank you for your attention. If you have further questions later, you can just email me as my Sharknet email address, and all the codes are available in my GitHub account that you can go through. The main resource that I used here, I want to show you, is the Comet website. It has the documentation and blog that you can use, and also the Comet GitHub project. So here is the Comet's GitHub project that I put the link in. So it has many information for you, many examples that you can go through and just do your code with the Comet. So these are the main resources that I've used here. So thank you, everyone. And if you have any question, I'd be glad to answer them.